Okay. Multiplying fractions. This is lesson 2-3. Okay, so we've already talked about multiplying a whole number by a fraction, right? We've learned a few things there. Okay, we've estimated them. Okay, now multiplying fractions, as mentioned earlier, you really just need to know your facts. As long as you know your facts, you're going to be in good shape. Truly. All right, so let's start off easy. So we have 1/2 times 5/6. I'm going to show you several different ways, maybe not to solve it, but things that you need to look out for. Probably a better way to put it. Okay, so how do we multiply fractions? Let's start there. Test. Okay, yeah, you simply multiply straight across. Numerator times numerator, denominator times denominator. That is correct, right? It's pretty simple stuff. Okay, the one thing that you really need to look for is once you've multiplied across, what do you want to make sure happens? Ken? Okay, you have to make sure that your answer is in simplest form. Okay, that is one common mistake that you make. As we've mentioned before, your teachers are not going to ask you to put it in simplest form. It's already a requirement. You don't have to ask. Okay, everything is in lowest form or simplest term. All right, that's the easy way to do them. Everybody good so far? I'll assume by your silence you mean yes. Okay. All right, so what about this? Okay, the one thing that you're going to want to do, okay, before you start any multiplication of fractions, there is something that you should look at to do before multiplying straight across. And the reason for that is you do not want large numbers. The larger the numbers, the more headaches. The larger the numbers, you probably forgot to do what we are about to do. What do you always want to look to do first? Okay, right? We talked about this last week. Cross, reduce. Okay, now I think in elementary school you said the butterfly thing, right? I think that's what some people said. Same thing. Okay, and here's where you got to know your facts. Okay, and when we're talking about cross, we're talking about diagonal. Right? There's a number that goes into 3 evenly, right? How about 3? So we divide. When you cross reduce, we divide. Now, here is where I would recommend that you rewrite the problem. Okay? Because when you cross them out, you're going to get a lot of numbers. So our problem really is 1/7 times 2 over 1. And from there, you can see that it's pretty easy. We get 2/7. 1 times 2 is 2. 7 times 1 is 7. That is in lowest terms. Okay, again, we're starting off easy, working to harder problem. Everybody good with those? Okay, now one suggestion. I know some of you may or may not want to do this, but if you divide, I don't recommend dividing in your head. I recommend writing it down. Because especially when you divide by the same number, in this case, 3 divided by 3, the most common mistake is you forget to cross them out and put a 1. You still multiply by 3 here going across. That is a common mistake. That's not a good mistake. So far, so good? Okay. What if we have something that looks like this? What's different here than in the other two that we have done there? Kendall? Say it again. Okay, you can cross reduce both ways. That is correct. It doesn't have to just be one way. Okay, if the problem lends itself that you are able to cross reduce both ways, then we need to do that. Okay, what goes into 9 and 3 evenly? Go ahead. 3, right? So 3 divided by 3 and 9 divided by 3. So we get 4 over 3 times 1 over 10. Okay. Does 4 go into 10 evenly? It does not. This is where you may just give up and say, darn, 4 doesn't go into 10 evenly. But here's where you got to know your facts. Is there another number that goes into 4 and 10 evenly? 5 does not go into 4 evenly. 2, there you go, that's better. 2 does. Okay. 4 goes into 2, 2 goes into 10 5 times. So our problem really looks like this. 2/3 times 1/5. I multiply across. I get 2/15. Can you do those in the same problem? Sure you can. Sure you can. But there's a lot of numbers going on. Again, I would highly recommend that you rewrite the problem so you're not confused on what you're actually multiplying across. Numerator times numerator, denominator times denominator. Kendall, question? No? You good? Question? Oh, we're going to do? Sure. Sure. All right. So if we have 15/24 times 4/30. How about that? Now, if we were to multiply across, children, we would get gigantic numbers. Do you agree? And this is not good, right? If we were to multiply across, we would get this, and we would get this. Okay, my experience is the larger the numbers, the more mistakes. Okay, is it okay? Excuse me. Is it okay to do it this way? Sure. But you better know some facts with between 60 and 720. Eesh. I don't want to go there. Okay. So, are there anything that we can cross reduce? Kendall, talk to me. We can do both of them. What goes into 15 and 30 evenly? Yell it out. 15. Very good. Okay, so if we divide by 15, very good. We now get 1/24 times 4 over 2. Very good. Anything else? Tessa? What goes into 4 and 24 evenly? Andy? Very good. So we'll do 4. This would be 6. This would be 1. So now our real problem that we're trying to solve comes down to 1/6 times 1/2, and we get 1/12. That is a lot better, in my opinion, than 60 over 720 to get down to 1/12. Kendall, question. Okay, you good with that, Gabby? Here's what I want to show you on this problem. Okay, we're going to redo this problem. Okay, what if we only recognized that we would divide by 3 here? And what if we recognize that we divided by 2 here? Let's do that. So this would be a 5, this would be a 2, this would be a 12, and this would be a 10. You agree? So now we have 5 over 12 times 2 over 10. We get 10 over 120. Right? Yeah, correct. We got to simplify, right? And then we got to divide by 10. And here we would then finally arrive at our 1/12. Okay, so what do we call up at the top here that we did? If we divided by 4 up here, which we did, and we divided by 15 up here, what are those numbers called? Do you know what those are called? Those have a name to them. Anybody remember? Something called a GCF. You know what GCF stands for? Greatest common factor. If you divide by the greatest common factor, meaning the largest number that goes into the two numbers that you're dividing, you won't have to simplify your answer. Okay, again, this goes all back to the beginning of being able to know your facts. If you know your facts, this is probably going to be really easy for you. Okay, no worries if you don't get the largest number. You're just going to have to divide again to get your answer in lowest form or simplest form. Does that make sense? Yes? Okay. Gabby, you good with that then? You good? Okay. So far, so good? All right. Moving on. Okay. What if we have something that looks like this? My first question is, do we need parentheses? So if we had this same problem that looked like this, would you agree that these two are equal? Yes or no? I see some yeses and I saw one no. What do you think? The answer is no, children. Those are not the same. If you're looking at the one in the green, 5 squared divided by 8, wouldn't that be 25 over 8? That squared symbol is not associated with the 8. It's only associated with the 5. But now that you have parentheses, the squared symbol is associated with both of them. This would be no different if we said 6 squared. Doesn't that look like 6 times 6? Okay, it doesn't matter whether it's a fraction or a whole number. Okay, whatever is inside of the parentheses is squared. All right. That being said, can we cross reduce? Anything goes into 5 and 8 evenly? No. Okay, sometimes you get stuck with this. So now you got to ask yourself, see, now those are two relatively big numbers. This is where you got to know your facts. Is there a number that can go into 25 and 64 evenly? What do you think? I'm seeing a lot of no's. Yeah, you're right. There isn't. So you're left with, that's your answer, 25 over 64. 5 doesn't go into it. 2 doesn't go into it. 3 doesn't go into them. Okay, it has to go into both of them evenly. So far, so good. Okay. What if we have this? We now have 3 fractions. Nine tenths times 7 ninths times 5 eighths. Can we cross reduce anywhere? The nines? Yes. The nines, right? We can divide by 9. Okay, we get 1 and we get 1. Can we do anything else? What do you think, Kendall? Okay, can we cross reduce the 5 and the 10? That is the question. What do you think? You're probably thinking, well, they're far away from each other. Okay, listen carefully. That does not matter. What matters is you can have as many fractions up there as you want, as long as you can cross multiply a numerator with a denominator. You are able to do that. Okay. So yes, I understand we're skipping the middle one here, but if we divide by 5, are we cross reducing a numerator with a denominator? Absolutely. That is perfectly acceptable. Okay, so for our question here, we get 1/2 times 7 over 1 times 1/8. That is a lot better looking at 9 over 10 times 7 over 9 times 5 over 8, my opinion. Okay, 1 times 7 is 7. 7 times 1 is 7. 2 times 1 is 2. 2 times 8 is 16. Is there a number that can go into 7 and 16 evenly? Nope, there isn't. Problem solved. So far, so good. All right. What if we have this? One half squared times 8/9 squared. My question is, how many fractions are going to be involved in this one? How many? 4. That is correct. So we got to write these out. 1/2 times 1/2 takes care of that. 8/9 times 8/9 takes care of that. There's 4 of them. Question, can we cross reduce? That's the question that you got to ask yourself all the time. It'll make your life so much easier. Yes, we can. If we divide by 2, we'll divide by 2 here. We get 1 and we get 4. We can also take the other 2 and the other 8. Divide by 4. Oh, sorry, 2. And we get 4 and we get 1. So if we rewrite it, we have 1 over 1 times 1 over 1 times 4 over 9 times 4 over 9. And when we multiply across, 16 over 81. 1 times 1 is 1, times 4 is 4, times 4 is 16. 1 times 1 is 1, times 9 is 9, times 9 is 81. Okay, again, pretty big fraction. 16 over 81. Is there a number that can go into 16 and 81 evenly? Okay, again, this is where you just got to know your facts. There is not a number that can go into both of those evenly, so we are stuck with 16 over 81. So far, so good. Okay, next one. Okay, we got P times 7/8 minus Q. All right, first thing we're going to do is what? What are we going to do? Plug in the numbers. Yeah, absolutely. P was 4/5 times 7/8 minus 1/4. Okay. What are we going to do? Okay. What are we going to cross reduce? Gabby. The 4 and the what? The 4 and the 8. Okay. Now listen carefully. Hang on. Can we cross reduce the 4 and the 4? I see a couple yeses and a couple no's. Okay. Those of you that say no, why not? Curious. Okay. Kendall says because it's a different operation. Those of you that say we can cross reduce the 4s, what do you say? Anybody? Okay, pay attention. We have to follow the order of operations here, correct? Cross-reducing only applies to multiplication. Okay. If you would like to put parentheses around these, that would probably be a good idea. You cannot cross-reduce the 4s. Kendall is right. That is a different operation. Cross-reducing only works for multiplication. Okay. So Gabby's right. We're going to divide by 4. Okay, so we get 1 and we get 2. If we rewrite our problem, which you should, you get something that looks like that. And now, if we multiply across, we get 7 over 10 minus 1/4. Now, what do we need to do? Andy, we need to find a common denominator because we are adding and subtracting fractions. Very good. What number shall we use, Andy? Very good, 20. Okay, so what you do to the bottom, you got to do to the top. Okay, in order to find 20, we have to multiply 4 by 5. What are we going to multiply the 10 by? 2, right? What you do to the bottom, you got to do to the top. So our new problem, 14 over 20 minus 5/20 will yield us 9/20. Is there a number that goes into 9 and 20 evenly? There is not. That is your answer. Okay, everybody good with those? All right, last thing I want to show you. They meaning they, the people that make up the exams, you need to know what a picture of multiplication looks like. Okay, so we got to make a picture or a model, whichever you so choose. So let's do 3/5 times 2/3. Okay, if they say model, that's a fancy word for picture. Now, at times, you may have to make the picture or you might have to be able to interpret the picture. Okay. So the easiest thing to do is one of these is going to be the horizontal. One of these is going to be the vertical. It does not matter which one is which. Okay. You might pick 3/5 as the horizontal. Your neighbor might pick 3/5 as the vertical. That's fine. You're going to get the same answer if you do it right. Your picture will just look differently. One will be long and horizontal. The other one will be vertical. Does that make sense? And you'll see here once we make it, right? Okay, so I'm going to make 3/5. I'm going to make 3/5 the horizontal one. And I'm going to make 2/3 the vertical one. Okay, and again, you can flip-flop them. It doesn't matter. I think you'll see here once we draw this out. Okay, so what does the 5 mean here in our horizontal fraction? That means that there's what? 5 pieces that make one whole, right? Okay, so I have 1, 2, 3, 4. I have 5 rows that make up one whole because that's my horizontal fraction. Don't worry about the 3. We'll get there in a minute. Does that make sense? Remember, you told me last week that the bottom number is how many pieces make up a whole. That is absolutely correct. Okay, and the 3 here in our vertical one means that we need to have 3 columns that make up a whole, right? So we have 1, 2, 3. See how that works? Okay. So far, so good. Okay, now the numerators here tell us how many we're going to shade in. Okay, so with my highlighter, look at this. There's 1, there's 2, there's 3. I shaded in 3 horizontal columns. I'm sorry, 3 horizontal rows. Okay, understand what I said. I didn't say 3 boxes. You shade in the entire row. Okay, vertically, how many columns am I going to shade in? I'm going to shade in 2, right? Not 2 boxes. I'm shading in the entire column. Does it make sense? Okay, from here, because you may not be given the fraction 3/5 times 2/3. They might just give you the picture. Okay. How can we determine our denominator if you just look at the picture? Kendall? How many what? Okay, how many different boxes there are, right? You just count up the boxes, right? There's 15. Right? You can look at this. 5 times 3 gives me 15. Okay, how do I get my numerator now? Okay, very good. How many shaded boxes have 2 colors in them? You see that? How many boxes have both colors is my numerator. That makes sense. Okay, if you notice, one thing that I want you to notice, if you take a look at the answer, 6/15, the one thing the model does not do for you is put the fraction in lowest terms. Okay, so I want you to pay attention to that. The model will not always put your answer in lowest terms. Okay, what goes into 6 and 15 evenly? 3, very good. So if we divide by 3, we're going to get 2/5. Okay, that would be the best answer in lowest terms. Okay, so again, make sure that when you do the model, make sure your answer, take a peek at your answer and make sure that it's always simplified. All right, any questions at all about multiplying fractions? Everybody good? Okay, again, highly recommended that you divide and cross out. Don't forget to cross reduce. Rewrite your answer. Yeah, some of these you can do in your head, but it could get a little bit crazy once you start. All right, so homework for lesson 2, 3. Okay, we're going to do 5 through 45, the odds. You're only doing the odds. Okay, if you have any questions, raise your hand or come see me.